Okay, so 10th question is there what domestic circuit, right? In that domestic circuit, first question is what are the reasons for overloading? Okay, this is the overloading. There are several reasons are there for overloading in a domestic circuit. First is what neutral wire and live wire, one direct contact with each other. So that will cause us a what that will cause us overloading. First contact of direct contact of neutral wire and live wire. Second is what sudden increase in the voltage, right? Sudden increase in the voltage means that also leads to the overloading. First the contact of neutral wire and live wire, that is called as overloading. And sudden increase in the voltage. And the third point, when the conducting wires like neutral wire and live wire is worn out. If any worn out means that any damage is there, leakage is there, means that also leads to the overloading. And fourth point we can write here, too many appliances connected in a single socket, this also leads to the overloading. Okay, so what are the four reasons for overloading? First neutral wire and live wire contact each other or directly contact each other. Neutral wire and live wire means that will cause us overloading. And sudden increase in the voltage, that also leads to the overloading. And some wires are like live wire and neutral wire are worn out, or worn out means some damage is there, leakage is there, means that also causes overloading. And fourth point is what, too many appliances we are connected in a single socket, that all leads to the what, overloading. These are the four main reasons of overloading. Direct contact of neutral wire and live wire, increase in the voltage, or worn out of the insulation of the wires like neutral wire and live wire. And fourth one is too many appliances connected in a single socket. These are the main reasons for what, overloading, right? Next here what they are given here, what is the need of 15 ampere and 5 ampere? Okay, so why we are why we have to apply, or why have to we use the 15 ampere and 5 ampere, means because in our home we are not using only one single kind of appliances, we are using different kind of appliances. For example, we are using AC, correct? AC, geysers, air coolers, right? Refrigerators, they will work under in the 15 ampere 15 ampere electric circuit, right? Again that fan, bulb, fan, bulb, right? TV, these all work under a 5 ampere circuits. If you these 5 fan, bulb, TV, okay, so we are connected with a 15 ampere, means heavy current will flow in these all appliances, and these appliances will be blast and it is not working properly, because the specified value of current for these TV, fan, bulb is only 5 ampere, but we are connected 15 ampere, means so these all will does not work properly, which rated under 5 ampere. In the same case, we are applied only 5 ampere, means the AC, geyser, air cooler, refrigerator, they will not work, because they need more than 5 ampere of electric current, but our circuit is providing only 5 ampere of electricity. So these appliances will not work because of insufficient supply of electric current. These will not start only because of they need more electric current, but our circuit is giving only 5 ampere. This is the reason we have to use different kinds of electric circuits, like 15 ampere electric circuit and 5 ampere electric circuit. 5 ampere electric circuit for fan, bulb, TV, like this you have to use it, and 15 ampere you have to use for AC, geysers, refrigerator and air cooler. So for that only we have to use or you have to apply the what, 5 ampere circuit and 15 ampere circuit. This is the reason we are applying two kind of circuits, right? Okay, next 11th question is what, explain an activity to determine the flow of current in different components, right? So we have to explain with an activity to different elements need different electric current, right? To demonstrate the flow of current in different for different components. For example, you have to draw here we will mark one point, here one mark, right? Here one battery we will connect, again key is there, right? Closed key, and we will show here ammeter to check the current, and it is should plus sign here, here plus sign. The positive, the conventional current is what, positive terminal to the negative terminal. Here the current is flowing from positive terminal to the what, negative terminal, right? So in the place of here x, here place and x y, correct? We are placed, we are took a nichrome wire, right? And in the place gap is there here, x and y, here gap is there. In that gap you have to put different kinds of appliances. For example, first we will put here one bulb, right? We will put here one bulb. Okay, so first we will put here, first case bulb will place here, correct? Bulb we will place, and second case what we'll do here, we will put here one torch, and third case we'll put here what, we can say that, okay, so we can for example fan will connect in the circuit, right? So here when we'll place the bulb means the for example in this 15 ampere, this is what current is flowing in the circuit is 5 ampere, right? So here when it is flowing in this connection in the circuit means it can electricity is passed through it, right? And in the when electricity is passed through it, so it will needs only 5 ampere. Instead of that, we are placed here torch bulb means, here torched means it can it not not it needs more electric current, right? It will needs what, more electric current. And again we connected in the fan means this also it will also works in a proper way. So in this manner we will say that different components will need a different electric component. So here it can work in a 2 ampere, it can work in 3 ampere, it can work in 6 or a 7 ampere. So different elements are need a different electric current. We can place with this fan, other we can change it a refrigerator, we can change it to refrigerator. I can also change with what, refrigerator with again we will take AC, right? All these equipments will need a different electric current, right? This activity will suggest that different components will need different electric current. Okay. Next 12th question is what, explain an activity to draw a field lines around a bar magnet using a compass and the magnet, write the properties of magnetic field lines, right? So first you have to draw a bar magnet, correct? It is a bar magnet, here north pole and south pole. When you have to what is the direction of this magnetic field in the near the bar magnet means you have to place here compass needle, correct? Compass needle having two direction, one is north and south, right? We know that north pole will repel each other because of like charges. North and south pole will attract each other because of unlike poles attract each other, and like poles will repel each other, right? Here we placed here compass needle, here north pole is there means it will attract it with what, south pole, right? Again we will place another compass needle means here again here north is there means will come here south, again it will come north, right? Here again will like this only you have placed in a proper manner means will observe in a like a this concentric manner of field lines, like north will attract south, south will attract north, like this only we are keeping the magnetic compass near the bar magnet means we will see that different types of water, sorry, we'll see that a direction of a magnetic field line around a bar magnet, like in a from north pole to the water south pole, it will be observing like this only. In the downside also it is moving like this, while we will place the compass needle, right. This will shows the magnetic field lines around a bar magnet, right. Okay, this is about the a bit answer, right. This activity about this bar magnet with the compass needle. Next, again they are saying that write the properties of magnetic field lines, correct. First point is they will start from, or they will start, we can say that they will emerge from north pole. The magnetic field lines emerge from north pole and merge at south pole, right. So what magnetic field lines will emerge from north pole and merge at south pole, first point, right. Second, what is second point means inside the magnet, the magnetic field lines is what from south pole to north pole. The magnetic field lines emerge from north pole and merge at south pole, right. And inside the magnetic field, the direction of magnetic field line is what from south pole to north pole. For example, here one bar magnet is there, here north, here south. They will emerge from here and merge at here, correct. I will see here, here they will emerge from what, here north pole to south pole, and inside a magnetic field the direction is what, from south pole to north pole. Okay, so they will start from north pole, right. They will emerge from north pole and merge at south pole, right. This like they will travel, they will merge at the south pole and emerge at yes, north pole, right. And inside the bar magnet, inside the bar magnet the direction is what, from south pole to north pole. This is the second point, right. Okay, so first point is they will emerge from north pole and merge at south pole inside a inside a bar magnet. The magnetic field line is what, south pole to north pole, right. A third point, they are closed curves. Magnetic field lines are what, closed curved lines. Okay, they always are closed curved lines. Magnetic field lines are closed curved lines, right. And fourth point, the relative strength of magnetic field lines is observed by what, a degree of closeness, means how much they are very close to each other. How magnetic field lines are very close to each other means that will shows magnetic field is stronger. As the magnetic field lines becomes larger and larger, or moving away from the conductor, that will shows the less magnetic field. Where lines are very closer, that will gives the what, more magnetic field, right. This is the fourth point. And fifth point, the two field lines never intersect each other, right. The two field lines what, never intersect each other. If they did means they will show two direction, which is not possible, right. So like what we said here, so north pole and south pole, right. These only closed curve we are saying, these closed and curved, these are what, closed and curved lines. Here we can see here, these are what, closed and curved lines are there. This is the magnetic field lines around a bar magnet, right. Here we can see these are what, closed curved lines are there, right. And also these lines are never intersect each other. These lines are never intersect each other, means they will not overlap like this. No, they will not go, always they go in a like a in a loop only. So they will go in a what, concentric the circle only, like from one point to the other point. They will not interact each other, they will not cut each other. If they did means they will show two different direction. It is not possible, right. This is the five properties of what, magnetic field lines. Okay, they will emerge from north pole to south pole, right. Inside a magnet, the direction of field lines is south pole to north pole, and they are what, closed curved lines, correct. and how much they are very close to each other, that will indicates the what, the more strong magnetic field. Like where it is near is there means that will shows the more magnetic field, where they are away from the conductor, like this distance is there, here to here distance is there na, here weak magnetic field is there, here weak magnetic field, here strong magnetic field. That is only called as a degree of closeness, right? And the lines will never intersect each other. So if they did means two direction is there, it is not possible, right? This is about properties of magnetic field lines, right?